Measurements Group Videotech Library. It is intended as an aid in learning how to successfully install strain gauges. Using micromeasurements gauges and installation accessories, this volume contains sequences on surface preparation, gauge bonding, lead wire attachment, and environmental protection for a wide variety of test conditions. Before using the techniques described in this volume for making actual strain measurements, be certain that the materials and procedures used are the correct selections for your specific application. This sequence covers general-purpose surface preparation for strain gauge installations. Properly prepared surfaces help ensure the strong, stable bonds required for transmission of surface strains to the gauge. The bonding surface must be chemically clean and free of paint, weldments, spalling, and other defects or contaminants. 5 basic operations are required: degreasing, abrading, burnishing of layout lines, conditioning, and neutralizing. We'll perform these operations on an aluminum alloy beam. You will need the following items to properly prepare the surface of the beam: CSM1 chlorinated degreasing agent, 320 and 400 grit silicon carbide paper, M-Prep Conditioner A, M-Prep Neutralizer 5, cotton-tipped applicators, gauze sponges, a 4H pencil, and a clean straight edge. The steps used in surface preparation are outlined in Measurements Group Instruction Bulletin B129. Check the expiration date to verify the freshness of both the conditioner and neutralizer. Take precautions when working with any chemicals. Safety measures for those used in surface preparation are described in Bulletin B129. Start by washing your hands with soap and water or with Neutralizer 5. Also clean the work surface before beginning surface preparation. Use a liberal amount of degreaser. Wipe the specimen surface thoroughly. To avoid recontamination, discard soiled sponges. Continue until the sponge comes up clean. Flood the gauging area with Conditioner A and wet lap with the 320 grit paper. Do not allow Conditioner A to dry on the surface. A dozen strokes is usually adequate. Wipe dry with a sponge. Use only once through the gauging area. With a refolded or fresh sponge, wipe away from the gauging area. Remove any excess chemicals from the work surface. Using 400 grit paper, repeat the entire wetting, lapping, and drying operation. Layout lines are usually needed to correctly orient the strain gauge in the bonding operation. With a clean straight edge and a 4H pencil, firmly burnish a layout line. Hold the pencil perpendicular to the surface. For harder specimens, use a ballpoint pen. A perpendicular line may also be needed for proper gauge location. Use a liberal amount of Conditioner A to remove all graphite from the burnished layout line by scrubbing along the line. Keep scrubbing, but check the applicator tip for soiled appearance. Continue until the tip comes up clean. Now, flood and re-clean the entire gauging area. Replace the applicators when they become soiled. As before, continue scrubbing until the tip comes up clean. Next, beginning at the edge, wipe dry with a gauze sponge. Refold and dry the remaining area. Neutralizer will provide the proper pH for good bonds with most strain gauge adhesives. Flood the entire gauging area and scrub thoroughly. Wipe dry with a clean gauze sponge. The specimen is now chemically clean and properly prepared for the installation of the strain gauge. Some materials will require alteration of the surface preparation procedures. Consult Bulletin B129. To minimize recontamination and oxidation, the gauge installation should take place within 30 minutes after the surface preparation is completed on aluminum alloys in a clean, dry environment. Times for other materials in other environments will vary. This sequence covers bonding of polyimide-backed strain gauges, including micromeasurements EA and CEA series, using M-Bond 200 cyanoacrylate adhesive. Prior to performing these operations, the surface must be properly prepared. In this case, the specimen is an aluminum alloy beam. You will need the following for bonding the strain gauge to the specimen. The strain gauge to be bonded. M-Bond 200 adhesive and catalyst. Gauze sponges. Neutralizer 5. Blunt-nosed tweezers. And PCT cellophane tape. The use of M-Bond 200 is described in Instruction Bulletin B127. Care should be exercised when using any adhesive system. Refer to the handling precautions contained in the bulletin. 5 basic operations are required. Gauge preparation. Gauge transfer. Catalyst application. Gauge bonding. And tape removal. Start by washing your hands with soap and water or with Neutralizer 5. Also, clean the work surface and tweezers. Carefully remove the folder containing the gauge from the plastic pouch. Hold the folder open in butterfly fashion. Grasp the gauge carefully at one corner. Avoid touching the grid area. Place the gauge on the clean work surface with the bonding side down. When properly oriented, the exposed solder tabs will be visible on the top surface of the gauge. Use a 6-inch length of cellophane tape to transfer the gauge. With the mastic side down, Center it over the strain gauge and press one end to the work surface. Hold the tape at a shallow angle and smooth it onto the gauge and work surface. Lifting at a shallow angle to prevent stretching the unbonded strain gauge, remove the tape and gauge from the work surface. Hold the strain gauge over the specimen with the alignment triangles over the burnished layout mark on the specimen. Check the alignment of the gauge. Reposition if necessary, again lifting the tape at a shallow angle. Press one end of the tape to the specimen, then smooth the tape and gauge into position. Starting at the end away from the gauge solder tabs, again lift the tape and form a loop to expose the bonding side of the gauge. The edge should be approximately 1/4 inch above the specimen surface. Tack the free end of the tape to the specimen. Before applying catalyst, wipe the brush 10 times on the lip of the bottle to remove excess. Now, using the side of the brush, apply catalyst evenly to the back of the gauge. Remove the brush by sliding it off the side of the tape. Allow the catalyst to dry for a minimum of 1 minute. Place a generous drop of adhesive at the junction of the specimen and tape. Promptly fold the gauze sponge into quarters. Free the end of the cellophane tape and hold it with light tension at a shallow angle to the specimen. Wipe the adhesive under the strain gauge and continue wiping with a single motion well past the gauge location. Immediately, place your thumb over the gauge and apply firm but comfortable steady pressure for a minimum of 1 minute. Remove the thumb with a twisting motion. Leave the tape in place at least 2 more minutes. We are now ready to remove the tape from the bonded strain gauge. This time, it is important to fold it back directly over itself. Slowly and steadily peel the tape from the specimen. The gauge is now ready for lead wire attachment. This sequence covers lead wire attachment on Micromeasurement's CEA series gauges for static strain measurement. In this sequence, we will make a quarter bridge installation. It will incorporate the 3-wire method of lead wire temperature compensation. You will need the following to attach lead wires to the bonded strain gauge: 326 DFV 3-conductor wire, a WTS thermal wire stripper if available, a Mark VI soldering station or other suitable temperature-controlled soldering iron, 361A 20R rosin cord solder, rosin solvent, paper drafting tape, diagonal cutters, sharp-nosed tweezers, dental probe, cotton-tipped applicator, a sharp scalpel, and M-Coat FA aluminum foil tape. The use of safety glasses is recommended during soldering operations. 6 basic operations are required. Lead wire stripping, lead wire preparation and tinning, gauge tinning, lead wire attachment, rosin removal, lead wire anchoring, cut the lead wires to the desired length. If a thermal wire stripper is available, use it to remove approximately 1 inch of insulation from the gauge end of the lead wires. A thermal stripper will not cut or damage the wire strands. If a thermal stripper is unavailable, use the Mark 6 soldering pencil. Set the temperature control to 570 degrees Fahrenheit. Remove all excess solder with a gauze sponge. Press the soldering tip firmly into the insulation, turn the wire, and repeat. Use the fingers to pull the insulation from the conductors. When the stripping operation has been completed, re-clean the soldering pencil with a gauze sponge and re-tin the tip. Separate the red insulated bundle of conductors and twist them together. Then, tightly twist the black and white insulated bundles together into a single bundle. Make certain that the soldering station is set to the proper temperature. Clean the tip with a gauze sponge and re-tin with fresh solder. Place the soldering pencil on the work surface and melt a pool of fresh solder on the upper side of the tip. Place a bundle of conductors in the pool of solder close to the insulation. To supply additional flux, feed fresh solder and draw the conductors through the pool. Continue to feed fresh solder into the pool. Now, with the scalpel, cut a 1/16 inch notch between the red and white wires and separate them slightly. For safety, place a finger over the wire ends before using the diagonal cutters to remove all but 1/16 inch of the tinned conductors. Again, clean the soldering pencil with a gauze sponge and re-tin the tip. Place the solder on the tab and press the pencil firmly through the solder to the tab and continue feeding fresh solder. Keep the pencil in contact with the tab no longer than 2 seconds. Tin the remaining tab. It is important to remove the solder and pencil simultaneously. The solder pillows should be smooth and hemispherical. If they are not, repeat the tinning operation. Press a 1-inch piece of drafting tape to the lead wires at the end of the insulation. Form a slight curve in the lead wires under the tape. Position the conductors directly over the solder pillows and tape the leads to the specimen. If necessary, adjust the position of the conductors with tweezers. Place the solder on one of the conductors. With a freshly tinned soldering pencil, press through the solder. Feed fresh solder for 2 seconds, Then remove the solder and pencil simultaneously. Solder the remaining tab and conductor. Leave the drafting tape in place. Flood the area around the gauge with a generous amount of rosin solvent. Use the brush to force solvent under the tape until it lifts free. Gently lift the leads and clean the surface underneath. Blot dry with a clean gauze sponge. Repeat the cleaning operation at least once. Visually inspect the installation to ensure that all rosin has been removed. Repeat again if necessary. With the tweezers and applicator, form a small strain relief loop about 1 inch from the gauge. In most applications, the lead wires should be secured to the specimen. A short piece of aluminum tape is used here, but numerous other methods may be used. Fold a pleat in the tape for additional strength. The gauge installation is now ready for electrical checkout and subsequent application of a suitable protective coating. This sequence details the correct application of protective coatings for strain gauge installations in a laboratory-like environment. Coatings protect against moisture and other contaminants which might affect gauge stability. Both encapsulated and open-faced gauges and their lead wire connections must be protected. A protective coating should be applied as soon as practical after gauge installation, even in an air-conditioned laboratory. Several preparatory steps generally apply to all protective coatings. If there is a possibility that the specimen has become recontaminated, it must be re-cleaned. Use Neutralizer 5 to clean an area larger than that to be coated. It should extend beyond the strain gauge and any excess bonding adhesive. Residual moisture will be entrapped by the coating and must be completely removed with a heat lamp or warm air blower. Lead wires within the protective coating should be separated. If they were not sufficiently separated during lead wire attachment, use a scalpel and tweezers to do so now. Vinyl and Teflon insulation must be treated to assure an adequate seal. Normally, these treatments are performed prior to stripping and lead wire attachment. Prime vinyl lead wires with a 50-50 mixture of M-Coat B and MEK. While applying it, avoid contacting the conductors. Allow 2 hours drying time. Teflon insulated lead wires should be chemically etched to produce a bondable surface. Use TEC1 Tetra Etch compound available from Micro Measurements. Be certain to follow the cleaning directions provided and to clip off the unetched end. Different application techniques are required by the various coatings. M-Coat A polyurethane, M-Coat C RTV silicone rubber, and M-Coat D acrylic lacquer are all supplied with brush-top applicator caps. These coatings can be safely applied directly to open grids and electrical connections. Brush over the gauge and lead connections, covering any exposed bonding adhesive. Be certain that there is adequate coverage under and around each lead wire. Refer to Catalog A110 for drying times and waiting period, if a subsequent coating is to be applied. M-Coat W1 is a microcrystalline wax that offers excellent waterproofing. A wax coating has limited mechanical strength and requires that lead wires be securely anchored to prevent movement. Heat the wax to approximately 170 degrees Fahrenheit. Also warm the installation with a heat lamp or warm air blower to ensure that the wax wets the specimen surface. Brush the coating over the installation with a clean, soft camel's hair brush. The installation is immediately ready with no additional cure required. M-Coat 3140 RTV and 3145 RTV may be applied directly over open-faced gauges and lead wire connections. 3140 RTV is self-leveling on horizontal surfaces and can be applied with either a brush or spatula. (3145) RTV, on the other hand, will not run when applied to vertical or overhead surfaces. It is best applied with a spatula. Full cure requires 24 hours for each 20 mils of thickness. Both will be tack-free in about 2 hours. The M-Coat F kit can be used for laboratory or field environments. For general laboratory applications, you will need only the self-adhering Teflon film, butyl rubber sealant, and neoprene rubber sheets. The Teflon should just cover all exposed electrical surfaces. On encapsulated gauges, cover only the solder connections. Press the film into place. The butyl patch should extend 1/2 inch beyond the open sides of the gauge and at least 1.25 inches along the lead wires. Remove the protective paper from one side. Beginning at the end opposite the lead wires, press the patch to the surface. Stop 1/4 inch beyond the solder connections, leaving 1 inch of the butyl exposed. Use tweezers to tack each lead to the coating. Then, with a dental probe, stretch the butyl around each lead. Avoid puncturing the butyl. The lead wires must be embedded in the sealant to prevent migration of moisture into the gauge area. Firmly press the remainder onto the specimen. Neoprene rubber offers excellent mechanical protection for the soft butyl. The piece of neoprene should be the same size as the butyl rubber patch. Remove the remaining protective paper and press the neoprene into place. M-Coat F is ready to use immediately, but adhesion of the butyl will increase over several days. M-Coat B is often used as an overcoating to improve chemical resistance and moisture-proofing capability of primary coatings. Using the brush top applicator cap, spread a liberal amount on the existing coating. Seal all edges and the lead wire entry area. For a complete description of these and other environmental coatings offered by Micro-Measurements, refer to M-Line Strain Gauge Accessories Catalog A110. At the Measurements Group, we believe that we understand the engineering aspects of strain and other structural measurements better than any commercial organization in our field. It's been our primary business for over 25 years. Through our involvement in the design and manufacture of strain gauges in our Micro-Measurements division, the wide range of strain measurement and calibration equipment in our Instruments division, and the materials and instruments for optical stress analysis in our Photoelastic division. The Measurements Group philosophy is to help our customers succeed. That philosophy is manifested by a dedication to the highest possible product quality. It also means a dedication to providing high-caliber technical support. In addition to this Videotech library, we offer an extensive selection of training programs in our specially designed Technical Training Center, a full-time staff of applications engineers, and a technical literature program that has become recognized as the foremost reference for strain measurement technology available anywhere in the world. If you have any questions concerning your specific strain measurement application, do not hesitate to contact us for additional technical assistance.